Hey everybody, welcome back to Young Engineers of Today. Hope you had a good couple of days. Yeah, we're going to continue with Arduino today. Like I said, I'm going to continue doing stuff with circuits.io, uh, just so you guys can watch what I'm doing. However, you guys are more than welcome to work on your physical Arduinos if you have those communicating with your computers. If you have those, A, and B, you have those communicating with your computers. If you do not, that's fine, so as it goes. Um, If you prefer to work with circuits.io, that's also great. If you just would rather do it physically, that's fine too. I know it can be more fun that way to be able to see it actually update in real time. Just keep in mind that if you work on it physically, it's going to be a lot harder for me to help troubleshoot it in case something goes wrong. Uh, Certainly with circuits.io, I can look at your circuit and look at your code and stuff like that and make changes to it pretty much instantaneously, if it comes down to that. Otherwise, yeah, you're welcome to do whichever one you feel. So Monday we spent getting everybody's Arduinos communicating with their computers. Today we're going to continue with those lessons, and we're actually going to continue with inputs. So we did analog inputs on not really much, Noah. You're fine. There wasn't any actual lesson stuff going on. Like I was just saying, if you want to, but that's entirely your choice. You don't necessarily have to, but if you prefer to do the physical connection, you're more than welcome to. Just keep in mind that if you do a physical Arduino setup, it'll be harder for me to troubleshoot. That's all. But otherwise, you're more than welcome to do whichever one you want. But like I said, we're going to continue. We spent time hooking up everyone's Arduinos to their computers. The video isn't up yet just because I had to do some extra editing on it. But keep an eye out for that. I should have it up either today or tomorrow after class, and we'll get it going. But there wasn't any actual lesson stuff that you missed, so don't worry about that. But yeah. So last Wednesday we did analog circuits. So we messed around with the serial prints, and we watched as the different values came through on the serial monitor. So if I change the value that the LDR is reading, you'll see different values come in on the Arduino through the serial monitor over here on the right-hand side. So that was the analog read. Today we're going to spend time messing around with digital read, because that's the other side of the coin. I mean, it would be useful to take a look at both of those. Digital read, thankfully, is a lot simpler than analog in many ways. The button wiring itself is a little bit more complex, but digital read on its own is much simpler. And why might that be? If anybody were to hazard a guess. What's the difference between digital and analog? Yeah, exactly, Jean-Marc. Yeah. It's just two values, either on or off. So that's a lot easier to mess around with, because we can, there are fewer values that we have to basically take into account. So digital read, our circuit is going to be a little bit more complex. We're actually not going to, we're going to ignore this top part right here. But we are going to utilize the button and the LED. So let's go ahead and see what we can do about this circuit. So I'm going to delete all this stuff. Delete that, delete that, delete that. We want to make sure we have our we keep our resistor, our 330 ohm resistor, or is this 10,000? I believe this is a 10,000 ohm resistor. Yeah, 10,000 ohm resistor. We'll keep the 10,000 ohm resistor because we still do use that. But we are going to add another resistor. We're going to add a 330 ohm resistor. And we're going to add an LED and a button. So just search for button. Let's get the smaller push button because that one's close to the size. Okay, so these are all of our components here. We have one 10,000 ohm resistor. We have one 330 ohm resistor. Let me go ahead and modify that so it's 330 ohms. We have one LED, and we have one push button. Obviously, we're going to have a bunch of jumper cables as well, or wires, jumper wires, jumper cables. We're going to be starting a car today, everybody. Anyway, we got a bunch of jumper wires as well. So make sure you have a good selection of jumper wires available to you as well if you're working on this on a physical circuit. Give everybody a moment to get that stuff together. At show of hands, how many of you are working on a physical Arduino right now? Okay. And how many of you are working through circuits.io? Okay, we got a lot of people working through circuits.io. I changed it. You can do a new one. It doesn't matter. Just as long as you have a setup similar to this one when you first start out building the circuit. You want to have your power and your ground rails all set up. So, okay, here's our push button. Notice how the push button is rather large compared to everything else we have so far. And like not too terribly large, but it takes up 4 spots on the breadboard. Notice also how those 4 spots conveniently straddle the middle rail on the breadboard. So that's exactly what we're going to do. We're going to place it somewhere where it's straddling the middle sort of dead zone on the breadboard. It's a dock time. Put it right here. There we go. The 2 resistors are 10,000 ohms and 330 ohms. Yeah, too much Halloween. English. Okay, so that's what we got so far. Not much, but we've got our 5-volt hooked up to the power rail, our ground hooked up to the ground rail, and then we've got a button that's straddling the dead zone. Now, the reason we're doing this is because, remember, these rails aren't connected across the dead zone. So we actually have this button hooked up to 4 separate rails. And a button works certainly these buttons work in a very interesting way. They don't bridge over from one to the other, although they might generally they do bridge along the same side. So this connection right here is always open. However, this connection right here or right here is generally only open when the button is held down. How do we know which resistor to change it to? I'm not sure what you mean. I'm not. Which letter with the little symbol thing? Still not entirely sure what you mean. You can just drag out two resistors though, and just set one to be 10,000 ohms and one to be 330 ohms. It doesn't matter which one you set to which. Oh, the K stands for 1,000. And the M stands for either million or mega, depending upon whether the M is lowercase or capitalized. If you want it to be 330 ohms, you just set it to the omega symbol and type in 330. If you want it to be 10,000 ohms, you can either type in 10,000 and set it to just the omega, or you can type in 10 and set it to the K omega, because again, K is short for 1,000. Kilo, like kilograms, kilometers, things like that. Yeah. Yeah, just for everybody's reference, we've got pico-ohms, nano-ohms, micro-ohms, milli-ohms, ohms, kilo-ohms, mega-ohms, and giga-ohms. And those might actually sound, those larger prefixes might actually sound similar to storage space in your computer. Bytes, kilobytes, megabytes, gigabytes, petabytes, or terabytes, petabytes. How do you change the resistance if you're working with an actual Arduino? You just need to use the proper resistor. You can generally, like resistors like these, you cannot change the value of. You just need to make sure that you're using the proper resistor. 330 ohms and 10,000 ohms. And in fact, in the SparkFun kit, they should only provide 330 ohm resistors and 10,000 ohm resistors. You have a blue one. As in it has a blue band on it, or it's a blue resistor? The body of the resistor is blue. Well, the body of the resistor can be whatever color. What we're interested in is the bands that are on the resistor. These colored bands here, see, like these resistors are brown, but okay, so he said that the blue ones were 10,000 ohms. All right. Apparently, Mr. Dubik said that the blue resistors are 10,000 ohms. Thank you, Jean-Marc. Yeah, you always want to be interested in the bands on the resistor because those actually tell you what the resistance is. The brown, black, orange resistors are 10,000 ohms, whereas the orange, orange, brown resistors are 330 ohms. Okay, so yes, what we're interested in is we've got the push button hooked up, we've got the wires hooked up. Let's start hooking up the rest of the components. We want to get these specifically oriented the proper way. So we're going to have the 10,000 ohm resistor hooked up to the button, and we're going to have the 330 ohm resistor hooked up to the LED. So let's go ahead and let's take a look at these. I'm going to plug in the LED over here. I believe yep. No, we're not going to do that. We're going to do this. So I'm plugging my resistor in to someplace, or excuse me, LED in to someplace that is entirely unrelated to the button. And the reason I'm doing that is because we're going to send a signal out to the resistor from the Arduino, or LED from the Arduino, to the LED from the Arduino. The button is going to be on an entirely separate circuit from the LED. We want to do this because, well, it gives us a little bit more control over how this is going to work. We can do it with the push button, but we want to take a look at how the Arduino handles input and how we can affect output. And this is the way we do it, or this is a way we can do it. So we have our cathode and our anode. Remember, the anode is the longer leg, I believe, on an LED. Let me double check that. Cathode is the shorter leg on an LED. Anode is the longer leg. We want to make sure that the shorter leg is hooked up to the resistor. So let's go ahead and take our 330 ohm resistor, and we're going to plug it onto the same side as the shorter leg. Now the resistor is plugged in onto the same rail as the shorter leg, and then the other end of the resistor is plugged into the minus rail. Now the nice thing about resistors is they can be oriented one way or another. It doesn't really matter. It's very important how we orient an LED, but a resistor doesn't care. It can be plugged in one way, you can pick it up and flip it around and plug it in the other way, and it's totally fine. But make sure that the LED, make sure the LED is plugged in a very specific way, and that is the short leg is plugged into the same rail as the resistor. So, as you can see, the short leg or the cathode is plugged into the same rail as the resistor. And then the resistor is also plugged in to the minus rail. Now, as you can see, I have it just jumping directly from this rail to the minus rail. You don't have to do that. You can use a jumper cable or something like that if you were so inclined, like I could go, oops, and, run a cable from here to the minus rail. For those of you at home, if it makes it easier for you, as you can see, they'll still all be connected to one another in a long circuit. But this is for clarity's sake on 123D circuits, at least on my end. So there you go. We've got our 10,000 ohm resistor hooked up to the minus leg, the shorter leg, on the LED. 300, did I say 10,000? I meant 330 ohm. Apparently I can't speak today. I can't talk. Having trouble talking. Okay, I did say 330. Excellent. All right, so now we're going to plug in our 10,000 ohm resistor, and we're going to plug in our power and our inputs. So you remember how I said a button will not jump across the dead zone unless the button is pressed? So we're going to have our input for the button be on this side of the breadboard for now. Well, for later too, but this helps give us an idea of how we're going to plug everything in. So the 10,000 ohm resistor is also going to be plugged into the minus rail, and it's going to be plugged into one of the terminals on the button. Just like that. So now we've got everything plugged in except for our jumper cables. So let's go ahead and spend some time doing that too. First things first, I'm going to connect this terminal on the button. Now notice it's on the same side of the dead zone as the resistor. That's important. We want to make sure that we plug the same side of the button as the resistor into power. Not the same terminal, but the other terminal that's on the same side. So I'm going to go ahead and plug this into the power, and I'm going to turn it into a red wire. Boom. So now we've got a wire running from power into the button, and presumably the power will stay on this side and run through the 10,000 ohm resistor unless the button is pressed. So far, so good. Now we're going to have our button give us inputs. We're going to take a connection from the other side of the button. In this case, it's labeled terminal 22 or terminal 22. But this is the one I'm going to use. So I'm going to take this and plug it into digital. Let's bring it down. Plug it into digital 2. And we're going to keep that wire green. So now we've got the other side of the button running to pin 2 on the Arduino. Digital pin 2, not A2, but digital pin 2. That's important. We'll want to make sure that it's going to be digital pin 2. Then we're going to take power on the LED. This is going to be output for the LED. And this is going to be plugged into digital pin 3. And we're going to turn this one a nice purple. That way we can easily tell the two apart. So let me zoom in a little bit more so you can see the circuit more easily. This is what we have. We have constant power running to one half of the button. There is a circuit here that will always be running no matter what, whether or not there will always be power running through the button because of this half. So we get power in from the Arduino, the 5 volts. Let me clean this up a little bit. My OCPD is kicking in a little bit. Boom, boom, boom. We got power running up through this wire, into the button, back out the other side, out the resistor, and down the ground. Anytime the button is held down, power will come out of this thing, go down the power rail, come up to the button, and then cross over to the other side and come out the green wire into digital 2. That's how we'll be able to read a value in. If the button is pressed, we should be getting a 0. If the button is not pressed, we should be getting a 1. As far as our LED is concerned, we've got purple coming from digital 3 out onto the longer leg on the LED, going through the LED, coming out the 330 ohm resistor onto the minus rail. We will eventually modify this code so that we will be sending power out onto the out of pin 3 whenever it's getting a result in from pin 2. That makes sense to everybody? I know I explained it kind of confusingly. So I'll give everybody a moment to hook up the circuit. Go ahead and raise your hands once you're done. Okay, we got a couple of hands so far, a few hands. If you're talking about this one right here, these two right here, yes, you would need those. That's so you can provide power and ground to the entire circuit. Anytime we're building a circuit, it's a safe assumption that power and ground from the Arduino are going to run to the plus and minus rails on the breadboard, unless I say otherwise. Just wait for a few more hands before we continue over to the coding side of things. Just a few more hands. Remember to raise them if you've got your circuit done. I'm going to sneeze, excuse me. That was a mighty sneeze. Okay, let's give it like 2 or 3 more minutes. Actually, let's say it's 7:30 on my clock. We'll start with the coding side of things. I apologize if you hear me sniffling too. I have like a bit of a cold, so I'm just sort of dealing with that. Okay, so let's get started on the coding side of things. So, what are the 2 things we always need? The backbone of every Arduino program. You got it. Bam. These bad boys right here. So, what we need to do now is we need to put a couple lines of code into void setup. What do we generally put into void setup for these types of circuits? Like what's a command you remember being in void setup a lot? Pin mode. Yeah, exactly. Pin variables and pin setups. Perfect. What we're going to do is, we're going to do our pin mode calls, and we're actually going to not use blah, 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 variables. We're just going to skip using variables entirely, just to make our lives easier. Pin mode 2, inputs. Pin mode 3, outputs. Let's take a look at our pins here. Interesting. That's because I paused my screen like a doofus. Okay. Yep, You're fine. Pin mode 2 input and pin mode 3 outputs. I'm a doofus. Now, if we look back at our circuit, we can see that pin 2 is our input from the button, and pin 3 is our output to the LED. So bam, pin mode 2 input, pin mode 3 outputs. Just like that. Look at that. So now we need to actually read those values and do something with them. So let's take a look at the code we used from last time, since that should still be sitting there in the code editor. It's a very, very simple line right here. Oops, let me get rid of the void loop. Serial.println analog read A0. Let's go ahead and dissect this real quick. Now this was for the analog inputs. What is A0? Do you guys remember? Yeah, it was analog pin 0 on our Arduino. Because remember, we had our circuit plugged into A0 on the Arduino. That was how it was reading power in on the Arduino. What about analog read? Based on analog read A0, what do you think is happening there? Precisely. It's reading the value of pin A0. It's taking an analog reading of pin A0. Now, it's inside a serial print line. So let's put this whole thing together. What was this doing every time it looped? And then doing what with it? Exactly. Exactly. So it might look a little bit more complex just because we have so many parentheses. There are two sets of them, but you know, when you get, yeah, anyway. We'll read this from the outside in. Every time void loop runs, it is printing something out on the serial monitor. What is it printing? Well, it's printing an analog read result. What's the analog read of? It's of pin A0. So if we put this whole thing together, every time void loop runs, the serial monitor is going to show a serial.println of a read of analog pin 0. So let's do a similar thing here. And really all we need to do is just change what's in here, because we're gonna print something out to the serial monitor every loop. Now, analog read was to read a value in on an analog pin. What if we wanted to read a digital value? What do you think we would use? You got it. Digital read. Of course, we need to put something in parentheses too. We need to tell it what pin to read from. So we're going to read from pin 2. Because remember, that's our input pin. So serial.println digital read 2. You do. Thank you. Thank you for reminding me. I forgot a thing. Forgot to begin our serial monitor. Serial.begin, and then in parentheses 9600. It's generally not well, it's not always going to be 9600, but it's a good starting point. So yes, thank you, Jean-Marc. You need to make sure we have the serial.begin 9600 in void setup. Otherwise, our serial monitor is not going to print anything out. That has to do with the rate at which it sends information, how often it sends information. I believe, or it's either that or how much information gets sent. Anyway, it basically has to do with the rate at which it sends information to the computer and the rate at which the computer is willing to accept information, as I remember it. Unfortunately, I'm not entirely on the up and up for it, but there are several preset values in the serial monitor related to, it's called baud rate. There's 9600, I believe there's 11,200, like 11,800, and a few other ones. But 9600 is generally a good starting point. So yes, serial.println digital read 2. That will print every time void loop runs and hits that command. That will print the result of a digital read of pin 2 out to the serial monitor. So let's go ahead and test this out. You'll notice that there are some other things missing, but whatever. So we got that into our code editor. I'm going to go ahead and upload and run it. And if we check the serial monitor over here on the right-hand side, it's saying 1, but if I press the button, nothing changes. So I've got a bug in my circuit, more than likely. I've done something wrong. Because we should be reading a different value. So let's take a moment to figure out what exactly I did wrong. I believe maybe if we move it over here. Yep, that'll do it. Okay, so that's what I did wrong. We need to make sure that this input is connected to a terminal that is diagonally opposite our power. So our power is going into terminal 2, 1. We want to make sure our input is coming from terminal 1, 2, if that's the case. If it's going into terminal 1, 1, you want to make sure that your input is coming from terminal 2, 2. Input is not declared. Interesting. Would you mind copy pasting your code into the chat box so I can see what's maybe going on? See if I click it quickly, you can see like just a bunch of 1s and 0s flying across the bottom right of the screen, or flying up the bottom right of the screen. Only getting 0s. Okay. Make sure your circuit is set up, at least like mine is. Did you use a capital M, Andrew? Or a lowercase m? You got to use a capital M. Because remember, computers are dumb. So even though we know it says pin mode, if you use a different, oh yeah, no worries, Jacob. If you use a different capitalization, the computer is not going to realize what you're talking about, and it's going to freak out. Perfect. Excellent. And yeah, no worries, Jacob. Take as long as you gotta. The only getting 0s. Yeah, double check your circuit. Make sure it's hooked up like mine. You've got the I've got the power going into terminal 2, 1 on the button, and I've got the 10,000 ohm resistor hooked up to terminal 1, 1, and then I've got the input for the Arduino hooked up to terminal 1, 2. Oh, excellent. Glad to hear it. You didn't even need me. That's okay. Everything's okay. All right, so I'm going to hold off on giving the code to you guys until I finish this code. Almost got it? Okay. All right, well, I'll hang tight for a minute and see what you've got there, Jacob. Jacob with a C. I see what it is, Jacob. Pin mode 2 is, you typed INT. Number of times I've done that, though. and on your void loop, you have serial.printin. Remember, it's serial.println. It's a lowercase l. It's short for print line. No problem. Okay, so back to the code at hand. So you've noticed, I'm sure you've noticed by now, that our LED hasn't done anything. We still have to set up our outputs. We've set up our inputs, but our Arduino is not doing anything except for printing it to the screen, which, you know, was a victory the last time it happened. But we want to do more with it this time. We want to actually influence the state of the LED based on whether or not we're pressing the button. So let's go ahead and add that bit to our code. After I do that, I'll go ahead and give you guys my finished code so that you can take a look at it and, you know, compare it to your code and everything like that. So we got two ways to go about this. One of these ways is longer than the other way, so I'll get more into it next Monday because it involves something called if statements, which are actually very useful things. But for now, we're going to do it the quick and dirty way, just so you guys can get it in and working and everything like that, and you know, have something that's usable. So digital read. That's when we want to read a value. What if we want to send out a value? Does anybody remember what that command is? Or can at least guess what it is based on what we have here? Yep, exactly. Digital write. So let's go ahead and we'll give a digital write value. Remember, lowercase d, capital W, digital write. All one word. But what are we going to send out on digital write? Well, remember how we sent the result of a digital read onto serial.println? And the result that we got on serial.println was either a 1 or a 0, right? As if I scroll up on this, well, they're all zeros now because it had been a minute since I pressed the button. But if there was if I was holding down the button, it would have said 1. Remember, digital write takes a pin and a value, either a 1 or a 0. So it stands to reason that we can probably send the result of digital read to it as well. That's the nice thing about programming, is there's all these modular blocks and you can just sort of plug them into one another like this. And it makes it super useful. So first of all, we have to send it a pin. Remember, we're going to be writing values out on pin 3 because pin 3 is our LED pin. And then the value we're going to send to pin 3 is going to be a digital read of pin 2. So digital write is going to send a value out on pin 3. That value is going to be determined by whatever we get from a digital read of pin 2. So let me go ahead and copy paste this code. Just a slight update into our code editor. I'm also going to put this into the chat box so you guys can take a look at it. And I'm going to upload and run it. Now that the simulation's running again, nothing's happening. But if I hold down the button, lit up LED. If I let go of the button, LED turns off. Hold the button, oops, lit up LED. Also, you can see in the serial monitor, we're getting a whole slew of 1s. Let go of the button, we get 0s again, and the LED turns off. Hold, let go. Hold, let go. Quickly press. You get the idea. So now we've got a push button. When we press it, it not only sends a value out to our serial monitor. Excuse me, one moment. All right, back everybody. Sorry about that. But yes, so whenever the button is held down, the value sent to the serial monitor updates. The Arduino recognizes the fact that it's reading an on signal. It's going to send an on signal back out to the LED on pin 3. As soon as we let go of the button, we get zeros. The Arduino sends zeros to the serial monitor, also sends no signal, zero, an off signal, um, to the LED. Can you hold it down so I know what it looks like, so if I know if it's lighting up or not? Certainly. So I'll start the simulation again. It's kind of a difficult, it's difficult to tell, but let's hold down the button. That's the LED on. What order do you put the resistors in? So the 330 ohm resistor is going to be hooked up to the LED. The 10,000 ohm resistor is going to be hooked up to the button. The reason we hook the 10,000 resistor ohm or the 10,000 ohm resistor up to the button is because we want to make sure that whenever the button is pressed, the resistance of the button is going to be lower than the resistance of the resistor. As long as so the resistor will always allow electricity through it. It's never going to be completely closed like the button is. So whenever we're not pressing the button is a closed circuit. My LED stays on whether or not the button is being pushed. Okay, so do you have a value, excuse me, do you have the long leg of the LED, the anode, hooked up to pin 3 on the Arduino? So, okay, so Andrew, if you mouse over the parts where the LED is, are you using a physical Arduino or are you using circuits.io? I know, I'm speaking with Andrew. Okay, yeah, Noah, again, just to reiterate on your question, you'll want the 330 ohm resistor hooked up to the LED. You want the 10,000 ohm resistor hooked up to the button. That's for you, Noah. And then back to you, Andrew, circuits.io. All right, so if you mouse over where the legs connect to the breadboard on your LED. Oh, okay, excellent. Glad to hear it, Noah. If you mouse over the breadboard where the LED connects to it, you'll notice that you'll get one labeled anode and one labeled cathode, right? Yes. Do you have the 330 ohm resistor hooked up to the cathode on the LED? Do you have the anode? See how I've got a jumper cable on the same rail as the anode? Is that hooked up to pin 3 on the Arduino? Okay. Now, we're looking at the button. You've got terminal 2.1, terminal 1.1, terminal 1.2, and terminal 2.2. Do you have power from the Arduino, basically the plus rail, is that hooked up to terminal 2.1 on the button? Okay. Do you have the 10,000 ohm resistor hooked up to terminal 1, 1 on the button? Okay. All right, excellent. I'm glad you did. All right, so that's going to do it for today. Hopefully, mostly everybody's got theirs at least up and running. If you don't, that's why we're stopping it now so we can start doing question and answer time. I'm going to do the poll questions because we can't go too long without doing those, and I know everybody enjoys doing them. So I'll go ahead and throw those out for you guys, not discard them, but actually throw them out your way so that you can answer them. And then we'll do question and answer time, and then we'll break for the weekend, and we'll meet up again on Monday. So here we go. First poll question incoming.